In this exercise we're dealing with the vector space R3, three-dimensional real space, and we have a set of vectors. Notice that each has three components. In fact, there's four of them, and there are three questions, and I prefer to just take them one at a time. The first question: is T a basis for R3? Now the answer is immediately a no, because we have four vectors, which is more than three, and four vectors can never be linearly independent in R3, and so if they're not linearly independent, then it's not a basis. Okay, so I'll make a note of that. It contains more than three vectors, so it's not linearly independent. So in part B, what if I rephrase this? We want to take maybe less than T, part of T, that will be linearly independent. Maybe throw out the last one, maybe throw out the last two, until we just get linearly independent ones. Now, how do we do that systematically? What we do is we take these four vectors and put them as rows in a matrix, and then we bring this to row echelon form. So let's see, subtract the first row times 4 from here, subtract it times 7 from here, subtract twice of it from here, and that gives us zeros here. Now we want to keep going. I want to get a 0 here, but look at this, they're all divisible. I can cancel. In fact, I can, the second row can be divided by -3, and this one can be divided by -6. And then we have three rows all the same, so of course we could subtract the second from the third and the fourth and make those 0. And there we are. Now, I'd like to just take the top two, but the thing is that these are not from the original set T. So what I can do is to notice that the top two rows just came from the top two rows that we originally had. If I just did the row operations on the top two rows, I'd get from here to here to here to here. So these are the two vectors that I want to take. They have the same span as these two. Just scroll, and I'll give it a name, T prime. And T prime now consists of the linearly independent set, and the maximum we can get is 2 vectors. Now the last part was to extend this, because we know that we could get 3 linearly independent vectors in R3. So what I'm going to do is, suppose I replace this last row by 0, 0, 1, just put a 1 here, then these two with this one would now be linearly independent, and again, instead of these two, I can replace them by these two, and so let's now call it T asterisk, is these two with an extra 1, and these are now 3 linearly independent vectors, and we're done.